Look up at the sky right now. See that brilliant ball of fire that gives us life, warmth, and energy? The sun won't shine forever. One day, it will die. But what happens then? In about 5 billion years, our sun will begin its death throes. The hydrogen fuel that has powered it for nearly 5 billion years will run out. The delicate balance that keeps our star stable will collapse. And when it does, everything in our solar system will change forever. The sun will swell to a monstrous size, potentially swallowing Earth whole. Then it will shed its outer layers in one of the most beautiful displays in the cosmos. Finally, it will shrink down to a dense, slowly cooling ember that will outlive our entire civilization by trillions of years. When our star dies, what happens to Earth? What happens to the other planets? And most importantly, could humanity survive? Today, we're going to witness the death of our sun. The sun today. To understand how the sun dies, we first need to understand how it lives. Right now, deep in the sun's core, 600 million tons of hydrogen are being converted into helium every single second through nuclear fusion. This process releases an incredible amount of energy, the equivalent of 100 billion hydrogen bombs exploding every second. This might sound violent and chaotic, but it's actually perfectly balanced. The sun exists in what astronomers call hydrostatic equilibrium. The outward pressure from nuclear fusion pushes against the inward pull of the sun's own gravity. For nearly 5 billion years, these two forces have been locked in a perfect tug-of-war. But this balance won't last forever. The sun burns through 600 million tons of hydrogen every second, and even though it contains an enormous amount of fuel, that fuel is finite. The hydrogen in the sun's core, the only place hot and dense enough for fusion to occur, will eventually run out, and when it does, everything changes. The hydrogen runs out. Fast forward 5 billion years into the future. Deep in the sun's core, the last atoms of hydrogen are being fused into helium. The nuclear reactions that have powered our star for its entire life are beginning to sputter and fade. Without the outward pressure from fusion, gravity wins the battle. The sun's core begins to collapse under its own immense weight. As it contracts, it heats up dramatically, reaching temperatures of over 100 million degrees Celsius. At these extreme temperatures, something new happens. Helium atoms, which have been the waste product of hydrogen fusion for billions of years, finally become hot enough to fuse together. But helium fusion is different. It's more violent, more unpredictable, and it produces far more energy. This surge of energy causes the sun's outer layers to expand dramatically. Our once modest yellow star begins to swell into a red giant, a bloated, angry version of its former self. The sun will grow so large that it could extend beyond the orbit of Mars. Its surface will cool and turn red, but its total energy output will increase by thousands of times. The gentle, life-giving star we know today will become a cosmic monster. Earth in peril. What does this mean for Earth? As the sun expands into a red giant, our planet will face the most extreme conditions imaginable. The first thing to happen will be the complete evaporation of Earth's oceans. Every drop of water that has ever existed on our planet, from the deepest ocean trenches to the smallest puddles, will boil away into space. The atmosphere that has protected life for billions of years will be stripped away by intense solar winds. The magnetic field that shields us from cosmic radiation will no longer matter when the source of that radiation is a bloated, angry star filling half the sky. But here's the truly terrifying part. Earth might not just lose its atmosphere and oceans, it might be completely engulfed by the expanding sun. Current models suggest the sun's outer edge will reach somewhere between the orbits of Earth and Mars. Whether our planet survives depends on factors we can't predict with certainty, like exactly how much mass the sun will lose during this process, and how that affects Earth's orbital distance. If Earth does survive, it will be a charred, lifeless rock orbiting dangerously close to a dying star. If it doesn't, well, our planet will literally be inside the sun. Meanwhile, the outer planets might enter a brief golden age. Jupiter's moons, Saturn's moon Titan, even distant Pluto might experience temperatures warm enough for liquid water. For a few million years, the outer solar system could become the new habitable zone. The final stages. The red giant phase can't last forever. Helium fusion is violent and unstable, causing the sun to pulsate and throw off massive amounts of material. Over the course of several million years, our dying star will shed its outer layers in powerful stellar winds. These expelled gases will form one of the most beautiful phenomena in the universe, a planetary nebula. Despite the name, it has nothing to do with planets. It's a glowing shell of ionized gas, illuminated by the intense radiation from what remains of the Sun's core. This nebula will expand outward at speeds of tens of kilometers per second, carrying with it the heavy elements forged in the Sun's core over billions of years. Carbon, oxygen, silicon, iron, the building blocks of planets and life, will be scattered into space, eventually becoming part of new stars and new worlds. But what about the Sun itself? At the center of this expanding nebula will be all that remains of our once mighty star, a white dwarf. This incredibly dense object will contain about 60% of the Sun's original mass, compressed into a sphere roughly the size of Earth. A single teaspoon of white dwarf material would weigh as much as a car. The surface temperature will be over 100,000 degrees Celsius, much hotter than the Sun is today. But with no nuclear fusion to sustain it, the white dwarf will slowly, inevitably begin to cool. What happens next? The white dwarf that was once our Sun will spend the next trillion years slowly radiating away its heat. It will fade from brilliant white to yellow, then orange, then red, and finally to a cold, dark object called a black dwarf. But here's something incredible to consider. The universe isn't old enough for a single black dwarf to exist yet. The oldest white dwarfs in our galaxy are still glowing hot after 13.8 billion years. The cooling process takes so long that the first black dwarfs won't appear for hundreds of trillions of years. During this unimaginably long period, what's left of our solar system will drift through space around this stellar corpse. If Earth somehow survived the red giant phase, it would be a frozen, airless world, orbiting a slowly fading ember in the darkness. The timescales involved are almost impossible to comprehend. If the entire history of the universe so far was compressed into a single year, the time it takes for a white dwarf to cool into a black dwarf would be equivalent to thousands of years. By the time our Sun finally goes completely dark, the universe itself might be unrecognizable. All the stars we see in the night sky will have burned out. Entire galaxies will have drifted apart due to the expansion of space. The cosmos will be a cold, dark, and empty place. Humanity's question. But here's the big question. Where will humanity be when all this happens? 5 billion years is an almost incomprehensible amount of time. To put it in perspective, 5 billion years ago, Earth was a young, hostile world with no complex life. The most advanced organisms were simple bacteria. Everything we think of as the history of life, from the first animals to the dinosaurs to human civilization, has happened in just the last 500 million years. In 5 billion more years, what will our descendants look like? Will they even be recognizably human? If our species, or whatever we evolve into, is still around when the Sun begins to die, we'll need an escape plan. Mars will be too close to the expanding red giant, but the moons of Jupiter and Saturn might become temporarily habitable oases. Europa, with its subsurface ocean, could become a refuge world. Titan, with its thick atmosphere and methane lakes, might develop Earth-like conditions. Even distant Pluto could briefly enjoy a spring-like climate, but these would only be temporary solutions. The ultimate answer would have to be interstellar migration. By the time the Sun dies, humanity would need to have spread to other star systems, other planets around other suns. Perhaps by then, we'll have mastered technologies we can barely imagine today. Maybe we'll build generation ships that can travel between the stars, or perhaps we'll find ways to extend the Sun's life, feeding it additional hydrogen fuel like cosmic engineers. The death of our Sun isn't really an ending. It's part of a cycle that has been repeating for billions of years across the universe. The heavy elements created in the Sun's core will be scattered into space, where they'll eventually become part of new stars, new planets, and maybe even new forms of life. The carbon in your body, the oxygen you breathe, the iron in your blood, all of it was forged in the nuclear furnace of a star that died long before our Sun was born. When our Sun dies, it will contribute to this cosmic recycling program, seeding the galaxy with the elements needed for future worlds and future civilizations. So the next time you step outside on a sunny day, remember, you're being warmed by a star that has been burning for nearly 5 billion years and will continue burning for 5 billion more. In cosmic terms, we're living right in the middle of our sun's life story. But that story will eventually end. The gentle yellow star that has nurtured life on Earth for so long will transform into a red giant, then fade into a white dwarf, and finally go dark forever. One day, our sun will die. The question is, where will we be when it happens?